We're live.
Okay.
I've got the right live chat. I've got the right co-host. I've got the right intro. Everything's good to go.
I need to open Audacity.
Yep. Audacity's open.
Having a moment of trying to remember which computer is attached to which piece of what. That.
Hopefully they're all attached to each other.
Well, so the problem is you're on a computer that's like 5 feet away from me on a cart.
Yeah.
And it's actually hardwired into the universe. And the computer in front of me, this one right here, which is attached to this right here, is on the Wi-Fi.
Do you want to hear the craziest thing? My internet service provider just decided to double my speed. So I went from 300 megabits per second to 600 megabits per second.
I'm okay with that.
Yeah, me too. I can't believe I'll admit this, but I actually really like my internet service provider. And I've liked them for like a couple of years now. I use Shaw in Canada, and they've been like really good. And their customer service
I'm in the
has been
United
good.
States.
And the price
we don't
has been...
have.
Yeah, you have like no competition or something.
Yeah, we have monopolies on the wires usually. So.
Yeah, Powell Zzinski says Starlink. I wish. Yeah, I'm sure they'll double my price next year, but for now,
yeah,
it's kind of surprising.
For now, it's good.
Yeah, and I've tested it, and I can't hit 600, but I can get up to about 550. So, but they didn't double the upload speed.
It still sounds kind of awesome.
Yeah, I know. 600 is good. All right. So now you're somewhere different.
I am in the attic of my house. We are in the process of setting up for the Hangout-a-thon this weekend. So we have multiple cameras set up on a special computer, and we have 10 gazillion giveaways set up to give away. I was cleaning up earlier and then left everything I was using to clean up all over the place. So this weekend, I and other members of the CosmoQuest team are going to be streaming 40 hours of science.
This number just keeps going up. I remember it used to be the 36-hour, and there was a 24-hour one, and now it's 40 hours.
Well, it started, the first one was 32. 24 was Extra Life.
Okay.
Then there was a 32 Hangout-a-thon. There was a 36 Hangout-a-thon. And this one's 40 because we need to raise $60,000, and we figured a few extra hours might help. So, yeah. If any of you have seen me changing colors at the mention of James Webb Space Telescope for the past several months, it's because we'd been warned that cost overruns, as well as changes to policy and things like that at NASA, just might lead to cancellation of our budget.
But shortly, everyone's budgets are going to get canceled, so don't worry about it. You just hide in the cancellation-ness.
Yeah, sadly, people do need to be able to like pay their phone bills and eat. And I'm trying really hard to figure out how to be able to make salary while my staff at least looks for new jobs.
But I was talking about the government shutdown.
Government shutdown, yeah.
And so
the thing with the government shutdown is they know that their salaries will come back eventually.
Right. But they may have to go find other jobs, depending on how long it shuts down for.
Yeah.
Yeah. All right. Well, let's move on. I haven't said hi to people yet. I'm going to say hi to...
Okay.
Cosmic Lettuce, Cecily Reichwin, George Lancaster, Graham W., Guido Bibra, Harry M., Henrik Bo Anderson, John Seffill, LKSSBBWS09, Nancy Graziano, Nichols B., Nightbot, Paranor, Paul Gracie, Powell Zersky, Rick Schwartz, Susie Murph, Thomas Setstrup, Umu, Yamagashi-san, Zapfan, and that's it. Hey, everybody. Welcome to this special holiday episode of Astronomy Cast. We are just over a week, 10 days to the end of the month, so we're going to do what we always do, which is we're going to give you the year in review and talk about our reflections on what happened this year, and then probably next week we'll do the year in preview.
Yeah.
And talk about what's coming. So
and we will lie.
And we will.
We don't mean to. It just keeps turning out that way because science.
Well, I mean, what do you mean lie? We made a bunch of predictions. Some of them came true. Some of them didn't come true.
That's true.
And
yes.
And we're not going to listen to our predictions because I think it's counterproductive. Like, then you don't want to make predictions. So I think we'll just keep doing this. We're going to make more predictions for 2019 and not review our predictions at all. I think that's
okay.
No, we'll probably briefly sample what our predictions were for last year and find out. All right. Well, let's get on with the recording.
Okay. I am recording on that computer. It seems to be set for the correct audio to go into it.
I'm recording.
I'm test. I am too. Sorry for what I just did to the. Okay, there we go.
Chad's ready. He's a pro. Astronomy Cast, episode 510, 2018 in review. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser, Cain, publisher of Universe Today. With me, as always, Dr. Pamela, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing okay. How are you doing?
I'm doing great. Back from my Hawaii holiday, well relaxed. Last episode, I was actually in Hawaii, and the episode didn't sound too badly with my portable recorder. Again, Zooms for the win. If you want a portable recorder, get a Zoom. They're the best.
Unless you're going through international flights, in which case they will get you detained and you will hate them.
Sure, but then you can record the whole experience and then, post that online and everybody gets humiliated. So, it's a double-edged sword for them. Now, before we get into this week's show, we want to give one last promotion for the Hangout-a-thon. Now, people, when they get this, it will have already happened, right?
It will have already happened, but we're taking donations through December 31st.
Okay, perfect.
Any funds that come in before December 31st help us out. For those of you who haven't heard yet, CosmoQuest lost its NASA grant. So we have a shiny brand new institute with over 100 PhD scientists to call our own and no funding to science with. And we're asking for your help to hold us over until we can apply for and hopefully get new federal funds. Yeah,
Pamela is the absolute master of writing, funding papers, proposals. That is the thing that she does the best. And now with the loss of funding from NASA, there's going to be all kinds of new funding requests going out to, I'm sure, the National Science Foundation and private foundations and maybe NASA again. But these all take time. And until then, there is the science team that's already doing the work, and we want to try and bridge the financing between what happens now and so people don't have to get laid off and we can kind of keep going. So if what we do through CosmoQuest and the work that we're doing to try and help bridge that gap between regular folks and working scientists, please watch the Hangout-a-thon and participate, and more importantly, help us out with your funds. And there's going to be lots of information at it's hangoutathon.org. Yeah. And we have a ton of giveaways. There's Funko Pops. There's all sorts of just random. It's largely stuff from Loot Crate. Yep.
So stay tuned for all of the giveaways. And every time our ticker crosses over a new $100 mark, we're going to give treats to the dogs. There's a dog cam set up.
Wow.
Yeah. So please come help, please.
Yes.
Hangout-a-thon.org.
We really appreciate and could use your help. And don't worry,
Yes.
this is temporary, and then all those funds will come in, and be back to business as usual, science as usual. But this is a tough time. So let's get on with the show. Actually, before we do, congratulations on winning a Parsec Award, Pamela.
Well, and congratulations to you
Yeah.
as well, and congratulations to Chad and Susie. We won.
We won, finally. We won. We've been in the running for Parsec Award for, it feels like a decade now. And
Yeah.
I had to go and make my own video series to win Parsec Awards, and you had to help out the astronomy
365 days of astronomy,
and that won a Parsec Award. But finally, Astronomy Cast won a Parsec Award. So congratulations to everybody involved, and a big thanks as definitely to Chad and Susie for helping with the show. All right, let's move on. 2018 was an incredible year in space news. Rockets launched, landers landed, spacecraft were born and died. We learned tremendous new things about the universe around us, and today we're here to look back fondly over the last 12 months to review the year in space that was. The year in space that was. One of the real advantages for me maintaining my new email newsletter is I've got this really great, concise list of all of the space news that happened. So just before the show, I said to Pamela, hey, should I prepare a list of the stuff? And she's like, oh, that'd be great. And it took me a couple of minutes because I got this great list. So if you should totally be on my email newsletter. But I was able to pull a list. I think I've got like 18 things. It was actually, looking at it, it was a big year. I think one of the biggest years that we've seen in the history of Astronomy Cast. So I am prepared emotionally for the show to run a little long, and will try not to get super anxious about the length of it. So do you want to pick from that lovely list and pick one that you want to talk about?
Oh man, so for me, Osiris-Rex is the most cool of the cool. We have a little spaceship that could. It took off all the way back in 2016, and just about a week ago, it made it to Bennu. So it's now at a near-Earth asteroid. It has begun its imaging run, and it's going to go in, and it's going to grab a rock and bounce back off and eventually make its way back to Earth. And one of the reasons that I'm so super cool, I find this project so super cool and I'm super excited, is CosmoQuest wrote the software that's going to be used in part to find the rock that they're bringing back to Earth. And this is one of the things that's also so frustrating, is it's like, you mean I might not be doing CosmoQuest while my software is doing awesome things?
Right.
Damn. Okay. And then it's, of course, sister program Hayabusa 2 at Ryugu. So we have spacecraft at a near-Earth asteroid that's a carbonaceous chondrite, and we have one at a near-Earth asteroid that is a meteor one, and we're bringing rocks back from both, and all the science is going to happen. It's awesome.
Yeah, and we were actually there, of course, for the launch of Osiris-Rex in Florida, and it's great to sort of see the whole system come together now. Now here it is at Bennu, getting closer and closer, and I loved it. Was like, we're now at this point where it's now in its high orbit, but when it was approaching and you were getting these full rotation images, and amazingly how Bennu, like Ryugu, looked like this 10-sided die, this, some kind of polyhedron that was floating in space. Clearly, this is a shape that we're going to see more of as we explore more and more of the asteroid belt and more of these tiny objects out there. But just so exciting to see the higher resolution as you're seeing the asteroid, as the spacecraft is approaching the asteroid, and seeing bigger and bigger details. And then when you see that full revolution of it, and you're like, oh, what's that, and what's that over there, and I want to see that rock up close. And I can just imagine the difficult time that the folks at who are running Osiris-Rex are going to have to make choices about which of these spots they want to touch down on. And I know right now they are shortlisting the potential locations where they're going to do their landing attempts. They've got a few landing attempts that they can make, and just this amazing idea that they're going to be able to collect a sample and bring it back to Earth. So I I highly agree. I would say that is, you know, you snuck in Hayabusa, which I had said as a second thing, but I think by doing so, I want to give Hayabusa then a little more credit, which is this amazing Japanese mission just came. I mean, obviously we had been all tracking it, but I don't think anybody had really expected how exciting this mission was going to be and how innovative this Japanese mission was going to be in coming together. The spacecraft was powered by a really cool ion engine, so it was very able to get there with not a lot of energy. It was able to approach its asteroid target, Ryugu. Same kind of thing. You saw this wonderful approach on it. And then it had a whole collection of ways that it was going to try and will continue to try to explore. And I think one of my favorite ones was the German lander, if we can even call that landed down on the surface of Ryugu and then just kind of flip-flopped around for a while.
It was essentially a wind-up toy.
Yeah, sampling whatever it could find until it ran out of batteries. And I just love, as a comparison, right, that the costs were very low and that it really looked like the Japanese were willing to just try every crazy idea to see what's going to work. And I love that balance of let's send a mission, but let's also perform a bunch of experiments at the same time and just new techniques to try this out. So kudos to both Osiris-Rex and Bennu. Osiris-Rex and Hayabusa. So
yes,
I'll let you choose another one.
Well, we can do kudos to a rock. I'm just not sure what it did to deserve the kudos.
Yeah.
So it's really been a year of spacecraft wins and spacecraft loses. And it's that punctuation of highs and lows where it's not like the 90s where it was just like things launch. Okay, we're cool. Things launch.
Let's wait 15 years for the thing to happen. Yeah.
Yeah. So we also had, of course, the delay of the Space Launch Systems and James Webb Space Telescope. And those delays increased the costs of both programs and mean other things can't get done.
So what was where we are right now is the James Webb, I think, has been pushed to 2021.
March 30th, 2021.
And the Space Launch System, I'm not sure what the latest date is, but it's definitely been pushed back beyond 2020. It was going to launch in 2019. I think now it's in 2020. I wouldn't be surprised if it gets pushed again. NASA did fairly detailed examinations of both projects and showed that the contractors had sort of dropped the ball on both of them. I believe it was Northrop Grumman working on the James Webb. They had cost overruns and problems with quality control. It was Boeing with the Space Launch System, and there were some problems with that. And so we are at this place now where these missions are gobbling up all of the budget. They're too big to fail, too big to cancel, but they're going to need billions and billions of dollars more before they can actually launch. And we're in this really kind of scary limbo with both of these missions. I mean, James Webb will be the most incredible telescope that human beings have ever launched, but it is...
And the greatest example of the sunk loss fallacy.
Well, yeah, I mean, that's the question, right? When do you throw in the towel and say, forget it, we're just not going to launch this thing? $6 billion, $8 billion? Yeah, it's a sunk cost fallacy. And then you match that with the Space Launch System, which will be the most powerful rocket system eventually ever launched by human beings when it's in its final Block 2 configuration, which looks like that's not going to happen. Yeah. While at the same time, you've got other really interesting rockets coming together from private companies. So that was a really rough year. It just felt like a lot of bad news just kept dropping. And clearly, the delays were already sunk into the machine, and we just didn't know. It's just that it hadn't been revealed. And this year we got all the bad news.
And one of the problems with the Space Launch System is there's a very, very limited number of launches planned. And with just a few score launches, and they're already planned out several years, here we are spending billions and billions of billions on development of a rocket that will launch 2 or 3 times a year, as opposed to Falcons, which go off 2 or 3 times a week.
A day. Yeah.
Yeah, twice in one day. So the question starts to become, are we better off? And this was actually getting asked at some political meetings in the past few weeks. Are we better off putting our eggs in a different basket and perhaps launching things in smaller pieces with the BFR or one of the other heavier lift? Yes, Space Launch Systems is predicted to be the heaviest launch vehicle we've ever had. But we can make things that are smaller, and that's okay.
And so I guess that leads into what was just an absolutely stunning year for the private launch companies, starting with, obviously, SpaceX. They broke the record for the largest number of launches ever done by any single organization, more than many countries. I think China was more, but so SpaceX just launched a ridiculous amount of rockets, and of course the piece de resistance is that they used rockets multiple times. So one of their rockets was launched a 3rd time, and several rockets were launched 2 times. So probably into, well, I don't want to make any predictions. That'll be next week. But you know, we're going to see rockets hit 4, 5, 6 times. And of course, this is going to seem crazy, but it's been so long. But the Falcon Heavy launched at the beginning of the year, and we were, of course, predicting the launch of the Falcon Heavy. There hasn't been another Falcon Heavy launch since then, but
he's jumping plans is the thing. This is Elon Musk. It's constant innovation.
Yeah, and so, you know, to see the 2 rockets land for the Falcon Heavy, not the 3rd one, that was unfortunate, but to see the 2 side boosters but land simultaneously was one of my greatest experiences as a space nerd. And to see, and there's going to be more Falcon Heavy launches in 2019 is the plan. And then that goes along with all of the plans that were going on with the Starship and the Super Heavy. We can't call it the BFR anymore. We don't even know now what this thing's even going to look like, right? Like, at this point,
there was this random tweet of, "Oh, I totally revolutionized everything," and
solved
it's
like, like, what?
Dude.
What is it going to look like? What's it going to be? We don't know. So the name has changed. We saw a new design where it looked very much like a Tantan rocket.
Yes.
Some kind of old-timey 1950s pulp fiction rocket. And now we're looking at, we don't even know what it's going to be like, because he's like, I made it so much better and I'm not going to tell you. So now we got to wait for all that. So still, like, SpaceX, you won. You killed it. You crushed it. You absolutely dominated this year. You made rockets land on top of rockets. You made rockets used multiple times, bigger rockets, and you, of course, gave us so much fear, uncertainty, and doubt about the future of what the Starship is going to do to the rest of the industry.
I just want video of them catching a fairing, though.
Yeah, I know. Poor
they
Mr.
have this
Steven.
speedboat with a giant net.
Yeah.
And the fact that they're like zooming around in the ocean trying to catch these fairings is deeply amusing to me. And all I want for Christmas is video of that occurring.
Yeah. No word, not a lot happened with Blue Origin. They had some more tests of the New Shepard. We saw the launch manifest information about the new Glenn, which is their monster rocket, but we're still waiting a couple of years for that to actually launch. But I've seen the building. I've seen where they're building the Blue Origin rockets, and it's big. Like they've got a huge facility out at Cape Canaveral where they're building new rockets. So I think I wouldn't be surprised if we get more details. And again, I can't resist going into 2019. I'm not going to do it. Pick another story.
Okay. InSight. It actually has a seismograph tilted 2 or 3 degrees sideways. A seismograph placed on the surface of Mars. Soon we will know whether or not the red planet is solid all the way through.
The launch and landing of Mars InSight on Mars was great. It was spectacular and went.
Well, the launch was not spectacular. The launch was rather boring.
Foggy.
Yes. Yeah. Quiet, muffled.
Were you there for that?
No, but David Joseph Wesley and Ruxin Phoenix were.
Yeah.
And I got reports.
West Coast, Vandenberg is apparently you never get to see your rocket launch. You can just see the fog, and the fog, you hear noise, and the fog sort of gets a little brighter over there somewhere. And
you have to go mountain climbing and watch it emerge from the fog.
Yeah. So it's a tough place to watch rockets launch from. But yeah, I mean, amazing, right? A super sensitive seismometer sitting on the surface of Mars right now. It's about to deploy its probe. It gave us kind of a recording of what the wind sounds like on Mars. It faked it with its seismometer.
It tried.
Yeah. It's still not an actual proper microphone on the surface of Mars, but what a wonderful thing to know. And of course, the big question is what's inside Mars? We don't know. Is it gummy bears or is
it
dragons? We don't know. And only with a seismometer that's going to accurately measure the temperature gradient from the core to the surface and a seismometer to detect the Mars quakes will we get a better sense and be able to rule out gummy bears or dragons and maybe go towards some combination of liquid, solid, metallic core. So, awesome. But I think with InSight, it's going to get very boring very quickly because it has placed its seismometer. It's about to deploy its temperature probe, and then it's going to have to listen very quietly. Can't do anything because it's going to be listening for everything. So I think we're going to hear a lot less news from InSight now that it's done all of its deployments. It'll be the
and it has landed somewhere so boring on Mars they couldn't figure out where they were located from horizon features, and they had to figure out where they were by imaging it with HiRISE.
Yeah. All right, so I'm going to talk about the sort of in human space flight. We had a bit of a scare, which was the Soyuz rocket launch, and this was back in October. There was 2 astronauts, cosmonauts, were going to go to space, and shortly just after the deployment of the solid rocket boosters, there was a problem with the launch, and they had to abandon and abort the mission. The astronauts were recovered safely, but this caused a big concern, which was that without a fresh Soyuz delivered to the International Space Station, the International Space Station could only go for a little while having astronauts on board until the astronauts would have to abandon the space station. And this was a big risk. This called into question this agreement that the Americans have with the Russians to be able to launch spacecraft, called into question just this whole program and the way this is done. And you could see this sort of, it had shades of the Columbia disaster and the Challenger disaster, that you could see that there was this big risk that was happening. And I'm glad to say just in the last couple of weeks, another Soyuz is launched, astronauts delivered safely to the space station, disaster averted.
It was one of those things. This occurred right when I got to Australia, and I was sitting there thinking, or it happened right when I got to Sydney, and I was sitting there thinking, I should probably go to bed. And then I checked Twitter, and I was like, I'm not going to bed until these people have landed, because they might have just pulled 9Gs, and that would be bad. It was one of these things where they got lucky because the second stage failed early enough that they didn't get as high up as they might have, which means that they didn't pull as many Gs as they might have on their way back down.
it still sounded like no fun.
Yeah.
Yeah. But it is a relief. Now, there was a lot of development in 2018 of the replacements. There's the Boeing Dreamliner, the CST-100, and there's the Crew Dragon capsule that is going to be coming from SpaceX. Both of those, we've seen a lot of development. Both of those aren't going to be tested until 2019 at this point. But
astronauts were selected and are being trained,
and the spacesuits have been made and all of this. So it's just like it would have been too late to save the station and to keep it crewed. And it a tremendous amount of work is done by the astronauts in maintenance to close the station down and just leave it running up there for 6 months, a year.
And then the cosmonauts just periodically attack it with a knife. That will be my favorite video of any spacewalk ever. Did you see that video?
I did. Yeah, they're just like digging into how to do. They were performing rocket surgery.
And it did coin the we now have brain surgeons and rocket scientists and rocket surgeons. So while mission control was like, no, you need to take a break and stop it. What are you doing? Except in Russian. One of the cosmonauts was just like going at it with a knife and shredding through the external insulation on the Soyuz capsule, trying to dig in from the other side and figure out exactly what it was that caused the puncture that they'd had that was causing the ISS to leak atmosphere.
Yeah. It was a really big year for space missions. Less of a big year for like cosmological news. I didn't find a lot of big cosmology news this year, but there was a lot of just things happening with missions. The Parker Solar Probe blasted off, becoming the fastest spacecraft ever launched by human beings. We got the first pictures of the solar atmosphere from Parker Solar Probe, with Mercury caught in one of these blasts coming out of the sun. And over the next couple of years, Parker Solar Probe is just going to get closer and closer and closer to the sun and taking pictures, the quality of which we've never seen. And I love just the construction of Parker with this gigantic heat shield that it turns to face the sun when it's at the closest point along its orbit to protect itself from the deadly radiation that's coming off the sun, and then it zips out into farther away anyway, and then comes back again. And a really exciting mission, a really great launch, and a really kind of exciting capability for us to be able to take these close-up views of what is probably the most important object in the entire solar system. We wouldn't be here without the sun, so it makes sense to kind of understand it a little better.
We did have, well, it wasn't the year of cosmology. It was the year of the exoplanet. The Atacama Large Millimeter Array has really hit its stride. It is returning image after image after image of protoplanetary disks, showing us how solar systems are in the process of forming. We've had the Kepler data is continuing to return results as people process it over. We have TESS launched, is checking out, should return planets.
Already has.
Okay,
yeah.
It already has. Just there's so much planet stuff, and then of course we have Gaia returning everything local, and it redefined local by kind of meaning everything in the everything in the inner part of our galaxy.
Yeah, I have continued to say that I think Gaia is, up to this point, the most exciting mission that's in operation right now. Whenever I look on AstroPH for news stories, I see multiple stories based on Gaia data. Here's all the pulsars around us. Here are all the white dwarfs around us. These are all, now we know how big the Large Magellanic Cloud is. And, it turns out we now know that Alberio is a visual binary and not an actual binary star. Like, it just goes on and on and on and on and on. And we found a sibling star to the sun. Thanks, Gaia.
Yeah.
Right? Like it just, by having that detailed knowledge of all of these stars, their positions, their locations, what they're made out of, and then matching that against other large surveys of the sky, you're just learning kind of whatever you want to find out. And we're only halfway through Gaia. We haven't even gotten to the best part, where it's going to start to dump tens of thousands of exoplanets into our lap, map out dark matter. It's going to single-handedly, I think, revolutionize our understanding of the universe.
And it makes the faltering of so many other observatories a little bit easier to bear. We had Hubble go down for a while, we had Chandra go down for a while, and we're watching as the great observatories, they're all well beyond their life expectancy. These are your senior citizens that when they pass, it's like, you lived a good life. We're okay with this. But we're not okay with this because we don't have future generations off being built. We have Gaia now, and there's no other great observatories really waiting. Apart
from James Webb. Remember James Webb? But, it'll never launch. So, okay. So you mentioned this earlier, but I thought I would just sort of shine a light on this, is that we lost a bunch of spacecraft this year, a lot of really important spacecraft. We lost the Kepler spacecraft, which of course had been on, we thought we had lost years ago, but they had come up with a really clever fix, and now Kepler was able to continue observing and finding exoplanets. We lost the Dawn mission. That was expected. It ran out of fuel after having visited both Vesta and Ceres. Ran out of fuel, but made some amazing discoveries about both of those worlds. And I think the one that really felt most heartbreaking was the loss of Opportunity. The Opportunity rover on the surface of Mars. A big dust storm took over the entire...
They're still listening for it.
Then
it's not...
Then we'll make that a 2019 prediction that we'll find Opportunity again. But
I want it to have a Princess Bride kind of, not fully dead, just mostly dead.
Yeah. I think it's dead.
Yeah, I do too.
Right. So, but I mean, a global dust storm took over the entire planet, was darker, it was thicker and sort of worse than anything we had seen in modern history in our observations of Mars. It was the worst dust storm that we had ever recorded, and reduced the light to the point that Opportunity wasn't able to fill its solar panels, wasn't able to keep itself warmed up, and in the cold Martian night, it ran below its critical temperature and died. So it's out there somewhere. Some future Mars explorer will use it to communicate for home and stay alive. So I'm sure Opportunity has another job. But thank you. I mean, Opportunity, of course, was only expected to last 3 months. Lasted, I don't know, like 1 million years. So
yeah,
it did its job, and it's bittersweet, but it sure did a lot of work.
And Dawn just ran out of fuel to point its solar panels at the sun. And so it's out there at Ceres
somewhere
doing its dead robot thing.
Right. Another interesting mission. This is a story unfolding, and this is the Chinese launched their Chang'e 4 lander, or Chang'e 4 mission, and they're going to be putting their next lander, and this time onto the far side of the moon. And this is, of course, the side of the moon that faces away from us. There is no dark side, but there is a far side. And for the first time, we're going to see the surface of the far side of the moon as a little Chinese rover is going to noodle around, and the complexity was being able to retransmit data back to Earth. And so China has already launched a relay satellite, to the far side, and so it's going to be able to transmit whatever the rover sees. So the relay satellite is in position, and right now the lander rover is on its way to the moon, and we're going to see the whole thing unfold next year. Can't wait.
So, yeah, that's cool. And planetary science seems to be really where a lot of the cool success is coming. And it's also where a lot of the politics is currently. I mean, so we had people being like, Space Force. No, please don't do that. The returning to Mars, the returning to the moon efforts. We continue to look forward to the Europa Clipper. Mike Brown continues his explorations of the outer solar system. And we have 2 fabulous new dwarf planets. And I don't know how to pronounce the second one.
I
mean, it is pronounced? Yeah. I want it to be like Faro or something.
No, Far Out, man. So the Goblin and Far Out are the 2 candidate dwarf planets that have been added to the list, but they're actually the other teams. That's not Mike Brown's team. That's the other team of planet hunters who are also finding all of the objects out there. But I think, you know, you mentioned Space Force, and I think that's a big part. Is that the Trump administration put a lot of emphasis on human space exploration. We saw good budgets for planetary science coming into NASA. So actually for space exploration and for planetary science, it's actually been a really good year. And it looks like the future of the budget, unless there's a government shutdown. Stay tuned. But for now, actually, both human space exploration and robotic space exploration look really well in place. A lot of projects that seemed underfunded have gotten fully funded. Projects that look like they were going to get delayed have gone forward. And there's a lot of really creative ideas that are coming together for returning to the moon, using that as a stepping stone to Mars. And we've heard this before, but yeah, I heard all the right things this year, all the right lip service to these goals. So we'll see what happens, how it all unfolds over the next. It'll make the inevitable cancellation that more heartbreaking. Man, I'm so cynical about this.
And you're not even the one who's going to be streaming for 40 hours trying to raise your salary for your staff.
Yeah, no, I know. I'll give you a couple of hours. I'll be there.
I know. If you want science and you think it needs more funding, put your wallet where your mouth is. Donate to CosmoQuest. Hangout-a-thon.org. We need your help.
A couple of more pieces of news. One that just came around just this week is we've learned that Saturn's rings are dying.
Yeah. I don't know what to say to that one. They're about 100 million years old, they now think.
They have 100 million years left. They're
okay.
about halfway through their life, so they probably are 100 million years old, and then they've got about 100 million years left.
Yeah.
And it looks like Saturn is just gobbling them up.
It's a thing.
Yeah.
Something reached its Roche lobe and got shredded, became the rings.
And if you listen back to older episodes of Astronomy Cast, we would argue about whether the rings were young or old. Turns out they're young and they're going to die. So
all good things come to an end.
Right.
The only certainty is the heat death of the universe.
But it feels fortunate that here we are in the solar system at a time when Saturn had these beautiful icy rings.
We keep finding things that break the cosmological principle, this idea that we don't live in a special time or a special place. We seem to at least live in a special enough time that we get to see Saturn's rings, that our planet is capable of supporting life and all these other things. And a lot of really good dice throws happened.
Let's see what else. So interesting, just a few more quick ones. There was some really interesting findings of underground water on Mars, and this was announced earlier this year. And of course, we know there's water on Mars in the form of the big polar ice caps, and now they found that there are icy sheets of water on Mars just below the regolith. But for the first time, they found what looks like some kind of underground lake, salty lake, that could be a reservoir of water that future explorers could tap into to be able to, and also could be an ideal place to search for life, because we know that wherever we have briny, salty water here on Earth, we have life. So it would be an ideal place to go and look.
And at the same time, the black streaks on Mars once again had people coming up with ways that they might not be water.
And I think one last thing that I've got on my list is we have to say a sad farewell to Dr. Stephen Hawking, who passed away finally after what's, like living with a terrible disease, ALS, for a longer time than many of us have been alive, and still continuing to do cutting edge physics, locked into a prison of his own body, was a celebrity, but also was still a working scientist. And unfortunately, this year he succumbed to his disease and passed away. And I think we all really felt the impact of his legacy, and it's sad to see him go, and to know that. But when you think about what we all do with our lives, our healthy, full-bodied lives, and what he was able to do with such a terrible condition, it always makes me go, I gotta do more. I gotta, I think what he went through and what he was able to accomplish is an inspiration for the rest of us to try to live up to our potential. And that's one of the things that I really think about.
And he wasn't perfect. There were lots of cases of basically, I'll just say, not niceness across his lifetime. But in terms of someone who accomplished a whole lot with a whole lot working against him, it's still kind of amazing.
Yeah. So if you have one, pour one out for Stephen Hawking if you haven't already. Eggnog. But and we'll miss you. We'll miss having your presence in sort of all of the science that's going on. All right, I think we went through all of the things that we talked about that happened in 2018. Next week, we will look forward into 2019 and try to listen. Maybe we'll listen to our predictions, see what happened, and make some more predictions that we will ignore for 2019. Pamela, as of course, it's been an absolute pleasure working with you, and here's to many, many more years.
To many more years.
All right, we'll see you next week. And come to the Hangout-a-thon and donate.
Yes.
All right. Bye, everybody.
Bye-bye. Okay, now to save.
Larry Beckham, I disagree. Space Force is nothing good. Oh, yeah, please don't. I'm sure we'll get nasty emails. I'm not saying that was a good thing or the right thing. That was a thing. I actually think it's kind of an irrelevant thing. I don't think Space Force is going to... I mean, space is already heavily militarized. If you don't think that it is, you know.
Yeah. This is episode 510?
Yeah. And space is heavily militarized, and militarized to the extent that is possible under the current Outer Space Treaty. And so unless we hear some new detail, I don't know what else they could do that they are not already doing or is illegal. So that's my feeling on that. So it feels like at the very best an organizational chart change, and at the very worst a violation on international law. Somewhere in between. All right, I've saved my episode. Let's get on. We got about another 9 minutes to chat with people and answer some questions, and then we will move on to getting prepped for the Hangout-a-thon. Larry Beckham asks, how much data is backlogged from the great observatories and other missions? Will it take years to catch up? Is there a lot of backlog data?
It's not so much backlogged as there's always additional science that can come out of the images. So with the Hubble Space Telescope, we have a myriad of data that exists in the Hubble archives where all of those images were taken for a specific reason. Someone proposed time, used the data to do a specific thing, but there's other objects in the field, there's new understanding that comes up over time, things change over time. So data will continue to be of use as far into the future as human beings can keep reusing the data. We still go back and process data from the Mariner missions, from the Pioneer missions.
Yeah.
As our ability to manipulate photons gets better, we're able to sometimes even find details in the data that we weren't able to see before.
A lot of those. I was gonna say, like, a lot of those missions, like the time on the Hubble Space Telescope is booked in advance by a specific team that is looking to make observations of some specific object for a certain period of time, and they're trying to collect their data for a research paper that they're working on. And then the next team gets their data, and then the next team gets their data, but all the data is released and available publicly. And so if you come up with some insight and you're looking for some kind of confirmation, you can go through all that data and all those data and find the, see if you can get some confirmation. But you just kind of have to luck out if somebody happened to look at the same thing that you're wanting to look at with the same filters and, in a way that's going to provide you some useful information. Where the onslaught of data is going to start happening is with things like there's the Sloan Digital Sky Survey, where you've just got someone saying, hey, let's just observe the entire universe in a way that anyone can then use that to look through and find asteroids and quasars and different kinds of objects. And then you've got what's about to happen with the Large Synoptic Survey Telescope, which is going to be dumping petabytes of data onto the internet that is just everything. And then it's going to be up to people to look through it. And that is a backlog to end all backlogs, right? Like, the challenge is going to be, can I dig through these enormous databases to find the needles in the haystack that I'm looking for? But astronomers will be mining that for decades. And as long as LSST just keeps rolling, they're going to find so much stuff. And then where you can go, I just found a new object. I wonder what that is. I wonder when it first formed. Well, let me look back through the LSST data for the last 6 years and find that moment when this object appeared. So we're moving into this time where the backlog will be something you'll be able to dig through.
Yeah, we're just not. It's what's called the Simon White Rocky Kolb debate of, do you have PI-led instruments where individuals propose for time to do a specific thing like happens on Hubble, or do you have the survey instruments like WMAP was a survey instrument? It did a single thing. It did it amazingly well. We now have an amazing map of the sky in the cosmic microwave background radiation.
And we still use it, like, again and again and again. They still, and with the Planck telescope, they just keep finding new interesting things in that data. And
these are two totally different ways to do science. And it's cool, and they're culturally so different. Yeah.
And both have their place. We talked a bit about the Large Hadron Collider and how we're at the point now where these specific targeted searches are starting to come up dry, and they're going to just start brute forcing it. Like, let's just turn it to 119 and then turn it to 120 and then turn it to 121, and then blast, and I'm just making up numbers here, and blast this collection of particles and that collection of particles, and just see what comes out of the interactions and see if you can start to discover new particles that way, as opposed to following a specific approach proposed by the theorists. They're just gonna crank up that machine and just see what happens. And there's value to both. Astro YYZ is saying, it's like going over old glass plates and finding new stuff with modern technology. Tabby Star was exactly that, right?
Yeah.
They made a discovery, and then they looked in old glass plates and found historical records of what that star was doing.
Brad Schaefer. Yeah, that was Brad Schaefer's work.
So it shows you just want to hang on to that stuff. More.
So I am due on a different phone call in just a couple of minutes. So
Okay.
do we want to wrap it up
Sure.
for now?
One quick question. Camden
Yeah.
Bassett asks, does anybody know if we're still able to see Oumuamua?
Your backyard telescopes can't, but they are still tracking it with other telescopes because they're watching its velocity.
Right. I think. But one of the Kepler couldn't. No. Spitzer couldn't see it.
Yeah.
But yeah, so it is theoretically still visible-ish, but it's gone.
Faint.
Yeah, it's not
Yeah.
worth looking at apart from tracking its position.
Yeah.
All right, well, let's wrap things up. So have a good call. Have good prep on the Hangout-a-thon. I will see you Sunday, I think, but I'm sure I'll drop in at some point. I'm
Awesome.
really looking forward to it, and you are a beast.
I don't have a choice. I know.
So that is dedication to the job. All right.
Okay.
Thanks, everybody, for joining us.
See you all.
Thanks, Pamela, and we'll see you this weekend.
Okay.
Bye.
Bye-bye.